Hello students. Now let's get into the another numerical problem that is based on the application of Kirchhoff's voltage law. So as many number of circuit problems if you keep on solving, you will be able to get an idea of what is the nature of the law, how this law need to be applied, and so in order to get the solution, what are the steps that we need to follow, how to apply the junction rule, how to apply the voltage law at various points, how to recognize the resistor, how to recognize the value of the current and the voltage that been developed across the resistor. So a lot of things you'll be able to analyze because you can analyze. So the basic thing is that you need to solve as many number of circuit problems. So let's get into the another type of Kirchhoff's voltage, another problem which involves this KVL application, right? So I'll draw the circuit diagram and let us start working the problem. So now this is the resistor. The value of the resistor is 20 ohms. Okay, the value of the resistor is 20 ohms and this is connected in series with a battery of rating 200 volts. Again you have another resistor of value 132 ohms. Okay, you have a value of 132 ohm. That resistor is connected in parallel with this 20 ohm resistor. Okay, so now you need to close this circuit. Again what I'm doing is I'm introducing another resistor of value 60 ohms and it is connected in series with a battery. It is connected with the negative terminal of the battery. The value of the battery, the voltage rating of the battery is nothing but 100 volts. This is how the circuit diagram looks like. So first we have this 20 ohm resistor that is connected in series with the 200 volt battery, and this 20 ohm is being connected such that it is parallel to this 132 ohm resistor, and this 20 ohm and 132 ohm are in turn they are connected such that they are parallel to the 60 ohm resistor, and the 60 ohm is connected in series with a 100 volt battery source such that the 60 ohm resistor is connected with the negative terminal of this 100 volt battery. So this is how the circuit diagram looks like. So you need to identify the value of the current that is flowing through this resistor, through this circuit diagram. Okay, so now what will happen is here this one is 200 volt and this one is 100 volt. So I imagine that from this 200 volt a current of value I moves from this 200 volt battery. This current passes over here, but before that I need to mark the points A, B, C, D, E, F. This is for your understanding. So now what happens is the current is flowing from the 200 volt battery. At this junction point it is divided into two currents. Since this is a parallel circuit, it is being divided into two currents. The first current is, let us assume that this current is I1 and this current as I2. So I1 is a current that flows through this 132 ohm resistor, and I2 is a current that flows through the 60 ohm resistor. Okay, so this is how the points have been marked and the currents have been identified, and the direction also is being mentioned in the circuit diagram. So now your duty is to find the value of the individual currents. So how are we going to do it? So first thing is that we need to apply KVL. This is again one example of the application of Kirchhoff's voltage law. So now what I'm going to do is I'm going to take these four corners A, B, E, F, A. A, B, E, F, A. So this is the loop. So I am traveling in the clockwise direction as usual in this loop. So A, B, E, F, A is the circuit loop that is taken into consideration. So now how I'm going to apply KVL. So KVL, if I am traveling in the clockwise direction, okay, while traveling in the clockwise direction, I encounter a current that is also going along with me, so what I do is I introduce a negative sign and I multiply the value of the resistor along with the value of the current. So it will be minus I into 20. Again I am coming here, again I am moving in the clockwise direction. While moving in the clockwise direction, I happen to encounter a current of value I1 that is flowing along with me. So what I do, I automatically assign a negative sign and I multiply the value of the current along with this resistance. So what will be the value of the current? That is I1 into 132. Minus I1 into 132. Again, while traveling in the clockwise direction, I happen to encounter the negative terminal of the battery, of the 200 volt battery. So when I encounter the negative terminal of the battery, first what will happen? I need to automatically assign a positive sign and introduce the value of this voltage source, so plus 200, and I need to equate it to 0. So these things should be equated to 0. Okay. So now what will happen? Minus 20I minus 132I1, that is equal to minus 200. So 20I plus 132I1 equal to 200. I am removing all the negative signs. 20I plus 132I1 is equal to 200. I am removing all the negative signs. So 2 10s are 20, 2 6 are 12, 1 2 6 are 12, I1, 2 10s are 20, 0. So 2 5s are 10, 2 3s are 6, I1, 2 5s are 10, 0. So it will be 5I plus 33I1 is equal to 50. This is equation number 1. So from this expression, I have obtained the equation, the first equation. So I have obtained the equation number 1. So what I'm going to do is I'm going to record this separately. 5I plus 33I1 is equal to 50 as equation number 1. So 5I plus 33I1 is equal to 50. So now what will happen? I am going to rub this entire thing. Okay. Since I have a limited space in this board, I cannot write the entire problem over here. That is the reason why I am recording all the expression on one corner of the board. Okay. So I have recorded the expression, the equation, the first loop equation over here. Now what I'm going to do, I'm going to take this BCDEB. Now loop BCDEB is the loop. BCDEB is the loop that needs to be taken into consideration. So what again, I am traveling in the clockwise direction. So while traveling in the clockwise direction, what I get is I encounter a current in the opposite direction. So what I do is I automatically assign a positive sign I1 into 132. Okay, while traveling I get I1 into 132. Again, when I am traveling in this direction, I encounter a current I2 that is flowing along with me. So what I do is that I introduce a negative sign. and I put I2 into the value of the resistor as 60 over here. Now again I reach the negative terminal of the battery. Since I reach the negative terminal of this 100 volt battery source, what I do is that I assign a positive sign. And I write the value of the voltage source and I equate it to 0. So what will happen? 132 I1. Okay, so I2 minus I2 into 60 plus 100 is equal to 0. So that will be 132 I1 minus 60 I2 equal to minus 100. Okay, so now what will happen? 2 6 are 12, 1 2 6 are 12, I1, okay, minus 2 30, 2 3s are 60, I2, okay, is equal to minus 2 5s are 10, 0, minus. So again 2 3s are 6, 2 3s are 6, I1 minus 2 15s are 30, I2 is equal to minus 2 2s are 4, 1 2 5s are 10. Okay, 33I1 minus 15I2 is equal to minus 25, or you can write it, this is how the equation, you have obtained the equation, so better write it as equation number 2. Now you need to record at the corner, at the top right hand side of the board. So that will be 33I1 minus 15I2 equal to minus 25 as equation number 2. Right, this is what I'm going to do it. So the entire this loop is over. Okay, I have solved everything. So now what I'm going to do, I'm going to rub this one. I'm going to rub this calculation. Now I have two equations for these two loops. Now if I apply Kirchhoff's current law, applying KCL at junction B, what will happen if I apply KCL at junction B? I have a current I which flows towards the junction, and I have two currents I1 and I2 that is moving out of the junction. So I can write I is equal to I1 plus I2. Let it be equation number 3. Right, let it be equation number 3. So once again, what I do is that I record the equation here such that I is equal to I1 plus I2, and I name this as equation number 3. I name it as equation number 3. Right, so I consider equation 1. Equation 1 is 5I plus 33I1 is equal to 50. So I am going to substitute the value of I in this equation 1. So 5 into, what is I? I is nothing but I1 plus I2. I1 plus I2 plus 33I1 is equal to 50. So therefore 5I1 plus 5I2 plus 33I1 equal to 50. So now what will happen? 5I1 plus 33I1. 33, 34, 35, 36, 37, 38. So 38I1 plus 5I2 is equal to 50. Okay, this is the equation. Let us assume that this equation is equation number 4. Okay, let us assume that this is the equation number 4. 5I, 33, 34, 35, 36, 37, 38. 38I1 plus 5I2. 5I2 is equal to 50. Right. So now what am I going to do is, I am going to record this at that on top of the board, on the top right hand side corner of the board, as 38I1 plus 5I2 is equal to 50 as equation number 4. Right, so I got two equations in terms of variables. In terms of this I1 and I2, I have two equations. So what can I do is that I can solve the two equations. So I am going to solve the two equations. So once I solve the equations, I will be getting the value of the individual currents. So 33I1 minus 15I2 is equal to minus 25 indicates my second equation, and I am going to take 38I1 plus 5I2 is equal to 50. This is equation number 4. So what I am going to do is, I am going to put this as 33I1 minus 15I2 equal to minus 25, and I am going to multiply equation 4 into 3. When I multiply equation 4 into 3, I will be getting 38 into 3. It is 138 into 3 is nothing but 114. So if I multiply equation 4 into 3, it will be 38 into 3 is nothing but 114I1 plus 15I2 equal to 3 zeros are 0, 3 5s are 15. So what will happen? 15I2 gets scored out. So 114 plus 33 is nothing but 147 I1 is equal to 150 minus 25 is 125. So I1 is nothing but 125 divided by 147, which is nothing but 125 divided by 147 will be 0.85, 0.85 ampere. So I1 is nothing but 0.85 ampere. So that is the value of the current that is flowing through the 132 ohm resistor. So again what I am going to do is I am going to record here I1 is nothing but 0.85 ampere. So I have recorded the result of this calculation over here, right? I1 is equal to 0.85 amperes. So now what are we supposed to find? The last part is we need to find the value of the currents I and I2. So for finding the value of current I2, what we need to do is we need to substitute in any one of the equation. So let us assume that we take equation 1. Okay, let us assume that we take equation 4. So 38I1 plus 5I2 is equal to 50. 38I1 plus 5I2 is equal to 50. As we know that we have obtained the value of I1 as 0.85, 0.85 plus 5 into I2, which is nothing but 5 into I2 equal to 50. So what is 0.85 into 0.85 into 38? 0.85 into 38 is nothing but 32.3. 32.3 plus 5I2 is equal to 50. So 5I2 is equal to 50 minus 32.3, right? 32.3. So that will be 50 minus 32.3, 32.3. 50 minus 32.3 will be 17.7. So that will be 17.7. Therefore I2 is nothing but it is 17.7 divided by 5, which will be equal to, divided by 5, which will be equal to 3.54, 3.54 ampere. So I2 is nothing but it is 3.54 ampere. So this is the value of the current I2. I2 is a current that keeps flowing inside the 60 ohm resistor. Okay, the value of this current I2 we have obtained as 3.54 amperes. Therefore I2 is nothing but 3.54 ampere. Right. So again what I'm going to do is that I'm going to erase this calculation part, because we have already found the value of I2 which we are supposed to find. So currently we have two values of current, that is one is I1 and other one is I2. So since we have I1 current and I2 current, we need to calculate this I. What will be I according to equation number 3? According to equation number 3. Okay, according to equation number 3, what is I? I is nothing but I1 plus I2. Therefore, we get I1 as 0.85 plus 3.54, which will be equal to 3.54 plus 0.85 will be nothing but 4.39 amperes. So this is the total current. I is the total current, 4.39 ampere. So we get I is nothing but 4.39 ampere. So what we are supposed to do? We need to record here. Let us record here as I equal to 4.39 amperes. So we got the value of I, we got the value of I1, we got the value of I2. Therefore, these are the respective individual currents. These are the respective individual currents, right? So we got I value as 4.39 amperes and I2 as 3.54 amperes and I1 as 0.85 amperes. So we have found it. So we are coming to the end of this problem. Okay, so this is how we need to solve. By using this circuit diagram, we need to find the value of the individual currents. Okay, thank you, and please don't forget to subscribe this channel.